Good morning. My name is Hidenori. I'm from Japan International Cooperation Agency. We are working for international development project like technology cooperation project. We are working on the publishment of geospatial information. And I have been working on the web map system and in collaboration with our friends in OpenStreetMap project, I have been using the open source software, free and open source software for Geospatial to run the national mapping service for our country. And we would like to make use of our technology to collaborate with mapping agency of other countries. And yes, we are using Raspberry Pi, which is a single board computer originally designed by Raspberry Pi Foundation in the United Kingdom. And we are using this small technology to collaborate with our friends in developing countries. Okay. We are using Raspberry Pi for two things. One is serving web maps, which is my specialties, and another is GNSS positioning. And regarding web maps, of course, some of our colleagues in the mapping department of developing countries, they would like to provide web maps. But they have several technical challenges like power failure or connection failure, or if we install the professional level server, there will be some problem like managing the huge professional servers. So that is why we start from small technology like Raspberry Pi. Another thing is GNSS positioning. We have several projects working on continuously operating reference stations, and we are trying to share some technology. But at first, we would like to share what is GNSS positioning and what is the condition we can use GNSS positioning, like we need open sky to make use of GNSS technology. In order to share some knowledge about these technologies, we are making use of Raspberry Pi so that we can start really small. And there's two things we are focusing on. One is capacity building, because as I said, we can start small and we can start from the bottom. We can share everything we need to actually operate and manage the system after our technical cooperation project is concluded. And another thing is we would like to share the new technology called Cloud Native Geo. Cloud Native Geo, I mean all the data set is stored in a single file. And we can share this information to one server to another server, including mobile one. So that is something we'd like to continue to concentrate on so that we can create more available service or more sustainable service we can provide to our clients. Okay, we actually have several projects running with these countries. The first line is a mapping project, digital mapping project, or developing national spatial infrastructure with Albania, Bangladesh, Bhutan, it's Djibouti, yes, sorry, and I'm very sorry, and Ukraine. We have a project which run the digital map or running the web map system. And the second line is about GNSS project. We have a GNSS project with Thailand, Jordan, and Senegal, and Thailand. We have several of these projects, and we would like to share what we found in collaboration with these countries. Today we have the system actually up and running in this small box. And we call it Smart Maps Portable because it's about sharing the maps in a modern way using the web map technology. Inside this box, we have Raspberry Pi 4B, and we have USB UPS, which is about $50 US. And we have external USB solid state drive, which is about 1 terabyte. And 1 terabyte is really enough to store all the global data, actually, like OpenStreetMap data or other kind of elevation data or other semantic data. And in addition, because we are also working on the positioning project, we have a small GNSS antenna, which is really a cheap one, $20 for maybe to be used in the car, actually. And we have a USB power bank for a kind of external battery life. So that is the things we are developing in our project. We have Raspberry Pi and power and SSD and GNSS antenna. And in addition, we have additional Wi-Fi antenna so that we can host the Wi-Fi network by itself. Okay. And yes, actually, today I have this computer running, and so I'm not sure I can serve for the hundred of people, but it's a kind of fast serve basis. I have Raspberry Pi, and I would like to run this as a web app server, and we actually have 3 different ways for our client to connect to this small server. One is a direct Ethernet connection. It's simple, connecting by wire. And the second one is what I am using. That is a self-hosted Wi-Fi access point. We do have an access point called Smart Maps Portable. And password is the same, Smart Maps Portable. So if some of them are interested in accessing this server, first, please connect to this network, Smart Maps Portable. I think Smart Map S is really important because we believe that single one map does not meet all the different needs. So we believe that Smart Maps S is really important because plural different maps should meet different purposes. And after connecting to this network, then contact https portable.local. That is the name of this small server. And then you can access the website. But first, you will see this kind of warning. Your connection is not private because this server is running in a really local network. In the local network, you cannot verify the certificate provided by this small server. So you need to click the advanced button, and then you can proceed to portable.local, which is, they say, unsafe, but it's, of course, actually safe. After you push proceed in portable local, you can see all the map. This map actually covers whole the area, and they have 3D data. Yep. This is a really simple MapLibre GL.js website, but with pmtiles.js enabled, because we store all the data in pmtiles format. And if you push Control drag, then you can see the 3D view because it contains all the DEM data of the world from the bottom line, NASADEM. I converted NASADEM data into terrain tiles and stored it into PM tiles, and that is inside this small device. And in our group, we have OSM Japan chapter friends, and they provide PM tiles version of vector tile of OpenStreetMap, and it's about 69 gigabyte. It's stored in the SSD, so it's a kind of self-hosted PM tiles. And in addition, because it has a GNSS antenna, I have recorded my track in this town, and all the tracks is stored in H3J format. H3 is a hexagon-based tile system developed by Uber. And yes, you can see how I arrived here. So that is what I have. And the recent performance boost is thanks to the new open source software called Caddy. Caddy is developed for scalable services. They can provide HTTPS service or HTTP3 service, high performance service without configuration. So I like this new web server, and thanks to this web server, we could boost the service, maybe faster in the speed, I mean. And thanks to this new server, the performance is better. So I copied all the LiDAR data for covering Nagasaki Prefecture. Nagasaki Prefecture is actually our my hometown, and I converted it into OGC 3D tiles, and the size is 414 gigabytes. If we are running this kind of 3D tiles on a server side or a cloud service, then I think it will take some money. But because we have the self-hosted small server, we don't have to pay additional money to run the service. So this is a demo of the 3D point cloud 3D tiles with served from cloud object storage. So if we use cloud object storage, then the performance is something like this. This is, of course, good for someone who are really interested in the 3D LiDAR data, but it's a little bit slow. This is a demo. We serve the 3D point cloud data from Smart Maps Portable, Raspberry Pi. Then the performance is actually better because that data source is located in the same local area network. And yes, I feel that the speed matters really. And yes, we can provide this kind of higher level service by using cheaper servers, but local server. So that is something I have found from using Raspberry Pi for providing web map system. This is how I use Smart Maps Portable. I would say this is a web map technology, but we are actually a kind of independent from the internet. We can use web map technology because this is really good technology and the browser is really good software. But we can go without the internet connection so that we can start small, we can learn a lot, we can experiment this technology, and if we are more confident enough, we can move to the internet, we can move to the cloud-based infrastructure or on-premise server, so that our friend in the mapping agency in developing country can have a step-by-step approach to implement the web map service, which can provide to their people in their countries. So that is Smart Maps Portable implementation of Raspberry Pi for technology sharing with our friends in the developing countries. And yes, this kind of activity is done under UN Smart Maps group. We are really open community of practice. If someone would like to share some technology on the application of web map technology, then we always welcome the participation of anyone. And we have, for example, Discord channel, or we normally use GitHub issue to share information. And yes, our main idea is that we would like to keep web map technology open. Web map technology is really, really good and hosted by many different platformers, but we would like to make use of this good technology by ourselves so that we can make use of this technology for our clients. And our focus is on testing new technology because our group, a kind of voluntary group, is not group to operate the service, but we just test the new technology and share what we found from testing these new technologies. Okay, thank you so much for your time, and that's all from my side.